Okay, so this first one here talks about angle 1 is 5 times the measure of angle 2. Find the measure of each angle. Well, first of all, one of the things that this involves is it's expecting you to understand two parallel lines, a transversal running through it. And this, to answer this question, the problem is assuming that you understand that this is a straight angle and that a straight angle has a value of 180 degrees. Okay? So it's saying that angle 1, this obtuse angle here, is 5 times greater than angle 2. Well, I'm going to say that angle 2 equals x, okay? And since angle 1 is 5 times greater, we're going to say plus 5x, because it's 5 times greater than angle 1, which is just x. And that whole thing has to equal 180 degrees. Well, this is 1x plus 5x. That's 6x. So if 6x equals 180, I'm going to do 180 divided by 6. 180 divided by 6. 18 divided by 6 equals 3. I add the 0, I get 30. That tells me that x equals 30. So that tells me then that angle 2 is equal to 30 degrees. But then it tells me that angle 1 is 5 times the measure of angle 2. Okay? So if angle 2 is 30 degrees and angle 1 is 5 times that, to find angle 1, I'm going to have to do 30 times 5. Well, 3 times 5 is 15. Add the 0, I get 150. That tells me that angle 1, my obtuse angle right here, has a value of 150 degrees. And sure enough, when I add 30 plus 150, I would get 180. So that's how you would do one like that. Now, this next one, the price of 2 roses and 5 lilies is $27. The price of 4 roses and 6 lilies is $42. Can you determine the unit prices for roses and lilies? Well, first of all, when it's talking about unit price is always out of 1. So I'm essentially trying to find the value of x and y, the cost of 1 rose and the cost of 1 lily. Now, sometimes it's going to say create a system of linear equations or solve a system of linear equations or something like that. It all means the same thing. This particular one just happens to be calling for unit prices. So I'm going to make x the cost of 1 rose. I'm going to make y the cost of 1 lily. So I have 2 roses. So 2x, 5 lilies, plus 5y, and it tells me that that cost is $27. So that equals 27. Now the second part of my problem tells me that 4 roses, which is going to be 4x, and 6 lilies, which is going to be plus 6y, combined to have a cost of $42. So when I look at this this system of linear equations, I need to decide how I want to do that. Now remember, there's multiple things you can do. You can put them in slope-intercept form. You can use elimination. You can use substitution. So you want to look and you want to think, what's the best way to do it? Well, what caught my eye is this 2 and this 4. And I'm thinking, well, if I multiply this equation by 2, okay, that I can eliminate. So I'm going to do that because that 2 times 2 is going to give me 4. So 2x times 2 is going to give me 4x. 5y times 2 is going to give me 10y. And 27 times 2 is going to give me 54. Now I can cross that out. I don't need it anymore. Now I can solve this by elimination by subtracting. Because 4 minus 4 gives me 0. Well, 6 minus a positive 10 is going to give me a negative 4y. 42 minus a positive 54 is going to give me negative 12. And if negative 4y equals negative 12, then y equals 3. And that tells me that the cost of one lily is $3. So I can put up there, lily cost $3. Now, I've got to go in and plug it in for my original equation. Now, if I remember my original equation, it was 2x plus 5y equals 27. Now, I want to use as small numbers as possible, so I like 2 better than 4 with the 4x. Now, I know that y equals 3, so if I do 5 times y, 5 times y, if y is 3, is 15. So that tells me that 2x plus 15 equals 27. Then to isolate 2x, okay, I'd have to subtract 15 from both sides. So minus 15 there, minus 15 there, that's 12. That tells me that 2x equals 12, x equals 6. That tells me that the cost of a rose is $6. All right, so one more. And this is something that you're going to see, I think, on your test, but I want to kind of point out what's happening. They're going to give you these tables, and essentially they're going to ask you at what month are the accounts going to be the same. Imagine you have two bank accounts. This one at the beginning had $55. This one had $125. And you see that there's a pattern for how they're going up. Well, 55 is going to 85. 85 is going to 115. And I can see, well, that I'm adding 30 each month. They're in account A. In account B, I'm going from 125 to 145 to 165. And I can see that I'm adding 20 each month. It's asking me during what month are the account balances going to be the same? Well, let's figure it out. So first of all, if I have month 3, okay, if I add 30 to 115, I get 145. If I add 20 to 165, I get 185. So they're not the same yet. How about month 4? I add 30 to 145, 175. I add 20 to 185, I get 205. Okay, so here we go again. Now, if I add 30 to 175 for month 5, I get 205. If I add 20 to 205, I get 225. Not the same yet. So we go to month 6. If I add 30 to 205, I get 235. Account B, we're adding 20. I add 20 to 225. I get 245. So then I go to month 7, starting to run out of space. If I add 30 to 235, I get 265. If I add 20 to 245, I get 265. So that shows me that after month 7, the balances are the same. That's just some trial and error. To me, that's the most straightforward way to do it, as long as you give yourself some room and figure that out. All right, talk to you later, 8th graders. Good luck on your test. Bye.